So this is called the syllabus. At Guelph, they're called the course outlines. I don't know, I guess we don't like Latin. So good to know about. The thing I would draw your attention to are the assessment breakdown. So in-class polls, that's part of your grade. There's 2 projects that'll be during the term. It's important you know the dates those are due, so you don't like go on vacation or something when that happens. And there's a final project, also has a due date. The other thing you should know is that part of your grade is peer feedback. So giving feedback to other people in the course, that's always due after the projects are due. So you'll submit the project, you'll read other people's projects, you'll give some feedback. That's all part of your grade. Don't miss those. So put them in your calendar so you know. Other things, the in-class polls, you're going to get some experience with that today. That's through Mathematize. So you should make an account starting on Wednesday's class so that you can get credit for coming to class and participating and being part of the discussion. But I think that's, you can read all the details if you want, but that's the 30-second most important things in the course. Any questions or comments about that or anything else on the course outline that you guys have spotted so far? Okay, let's see what else is in the course. The other thing that I will introduce you to is under content. You go to content, and then you go to important links. And under important links, believe it or not, there are important links. Okay, so what important links are there? One of them is called the pre-class video playlist. And if you click on that, it should take you to something that looks like this, the pre-class video playlist. It's actually just a big Google sheet, and it has links and dates. Can I make this bigger for you? Let's see. Okay, well, we're gonna look at the tiny version because that's what we got right now. I'm gonna click on this. The current window is too small. I know, Google. Thank you. Okay. So it's a Google sheet, and it has dates. So here is the first day. Oh my goodness. I promise you, on a regular computer, it is not so small. Okay, there we go. The first date, that's today, Monday, September 9th. This is the first class, so there's no videos to watch before today's class. But starting on Wednesday's class, there are a bunch of videos you're supposed to watch. So there's actually 3 of them. One of them is optional. This is a very famous kind of statistical learning book called Intro to Statistical Learning that goes back many years. And these guys were one of the first people to make an online course. So they have these videos. I think they're like 20 or 30 years old now. So the first video you watch, 1.1 opening remarks of these guys 20 years ago. And then recently they made a Python version. And now they're all old. So they're 20 years older. And now they're laughing at themselves being older. I guess they're only 8 years later. So that one's optional. That one's just for fun. But these other 3 you should watch. So opening remarks, supervised versus unsupervised learning, and statistical learning and regression, those will be the topics on Wednesday's class. You should watch the video. I'm going to ask you questions in the polls. We're going to have a discussion, but I'm sort of assuming that you've already watched the videos and have like a little background on what we're doing. It's not a big surprise. And the dates are all here for the whole rest of the year. If things change, if the schedule change, I will let you know, and things might change if we get ahead or behind. That's an important link. Any questions or comments about the important link or the movies? The videos? Okay, that's one important link. What other important links are there? The course textbook. Again, this is related to the videos. It's the same book, An Introduction to Statistical Learning. These are the people who made the videos. So Robert Tibshirani and Trevor Hasty are the 2 guys in the videos. We're doing the Python version. So you click on it, it's like a free textbook. Very nice. Nice big PDF file. And there's also, if you go to resources, if you go to the ISL Introduction to Statistical Learning with Python, it will take you to some data sets and figures and things, also useful. And it's all free online. You don't have to pay for the textbook. Okay. Questions or comments about this important link? Not yet. Okay, yeah, good. Mathematize, I told you about this. If you click on this, it will take you to make a link, to make an account, and then you'll be able to use the account when you answer the polls and get credit for them. CampusWire forums, these are forums where you can ask questions that will be seen by all the other students in the course and answered by me. So they look like this. And right now I have a poll for you guys. How are your Python skills that you can answer to let me know how you feel about Python? Let me show you what it looks like for one of my other classes that's already been using it for a while. So this is one of my other courses this term, and the students have already asked a bunch of questions. Here's a question that a student asked. I just finished working on this. Why would you need to do this? And then down here is my answer. and so on. And other people you can comment, and we can have a nice discussion. You can learn things this way. So if you watch the videos and you have a quick question, you can put it there. We can talk about it even before class starts. And whatever you guys talk about can also inspire what happens in the actual lectures. So this is a nice thing. I usually, if you're very active on here, I sometimes give bonus marks at the end of the course for participating and trying. So those are the CampusWire forums, which are optional, but a really great resource where you can ask questions and things. Questions or comments about the CampusWire forums? You will need the secret 4-digit code that is listed in course links to get in, but hopefully you can figure that out. Okay, what other important links are there? The course website. This is my course website. This is what it looks like, Introduction to Data Science. Oh, yeah, the most important thing you need to know about the course website is you press this little button, it puts it in either day mode or night mode, okay? So it kind of has a list of all the lectures. This is all from the 2023 version, so 1 year ago. If you click on this playlist, it'll have recordings of all of last year's lectures. And then here are the topics by lecture. This year, I'm sure will be slightly different, but the same kind of idea. And it is a little bit like a Wikipedia-style page. So these are the topics we covered in Lecture 1 last year. Lecture 1 means like Wednesday's class. And if you kind of mouse over them, it'll give you a little brief introduction. You can click on it, and it'll take you to that page and about what these things are. And you can find the links and so on. So this is a little kind of like Wikipedia-like page of all the topics we're going to do in the course, if you want to read about things rather than watch videos. Okay, is that it for important links? That's probably the last important link. The course GitHub, as we go through the course, when I post code examples, you can always get them at the course GitHub, so you can run them on your own and try the ideas out in the programming. That probably won't come up till next week. Okay, that's it for important links. And that's what's on the course website right now. Any questions or comments about any of these? Yeah?
I'm also an Obsidian user, so can I get a copy of your, like you're using the publication?
Yeah, that's right. So this is this little purple gem you see over here. This is something called Obsidian.
Can I get a backup for this so that I can?
Yeah, sure. If you want the files, I can give you the files. Yeah.
Okay, thank you.
So all these files, these are called Markdown files, and this program Obsidian organizes all your Markdown files into this nice Wikipedia-style thing. A Markdown file is a file that accepts LaTeX commands. So everything is written in LaTeX. If you know about LaTeX, let's find one that has a lot of nice math LaTeX. You see these little Y hat and these little things. These are all written in LaTeX, and there's text files underneath that make them all. I can send them to you if you like. Yeah.
Thank you so much.
All right. Anyone else for questions? Okay. So since there's no questions, let's do some data science. All right. And the first question in the course about data science is over here on something I call the Netflix problem. Actually, can I get there directly? Here it is, okay. The Netflix problem. So what I want you to do is get into a group of approximately 3 people, so the people near you. There's about 15 people in there, so we'll have about 5 groups of 3. You should introduce yourself and tell them what your favorite math problem was. I never did the favorite math problem. Okay, we can do that. I gotta reveal. These are the favorite math problems you'll be revealing to each other. Reveal. Is this gonna work? Word cloud, here it comes. Oh, let's make it big. All right. So, what were everybody's favorite math problems? Algebra is the biggest. I'm very surprised. Most people hate algebra. Is linear on here or just algebra? Okay, linear algebra. Linear, very small. Linear algebra, hated. Algebra, loved. 2 plus 2, solving, topology. Let's see. Let's go through them one by one. So I can also go to submissions here. Advanced linear algebra stuff. This will come up later in the course. We're going to be doing eigenvectors and eigenvalues and talking about what that has to do with data science, how you can get stuff out of that. A hidden Markov model also uses linear algebra. So if you don't like linear algebra, you will not like a hidden Markov model. Solving a linear equation, that's also a type of linear algebra. Response for algebra, but no linear. So you should learn to love the linear part. Multivariable analysis. Regression, we'll be doing starting Wednesday and next week. Statistics, somewhat broad. What's your favorite math problem? Math, okay. 2 plus 2, 1 plus 1. SVD is exactly the thing I talked about of using linear algebra to decompose a data set. So I guess you guys are going to love that when we get to it. That's right at the end of the course. Euler's equation in all caps, love it. Okay. The problem with Euler is there's so many things named after him, I couldn't tell you what Euler's equation is. I guess, is it a differential equation? Ah, okay. E to the I pi. This equation. Okay. There you go. Yes. Okay. There's also an Euler's equation which is like this: y prime plus cy.
Cosine also, right? Cosine sin x.
Yeah. Okay. There's another one like this: e to the ix. Let's put theta to be fancy. Equals cos theta plus I sin theta. This is the other version of Euler's equation. And to get this one, you plug in theta equals pi. Theta equals pi. Okay, but there's another one that's like a differential equation that you learned in differential equations class, and I remember that one sucked. So this one's cool, but that one's just like annoying and painful. I think it's like this. You put like this. Yeah. This differential equation. What's the solution? Apparently Euler did it. Okay, I'm going to stop talking about Euler's equation. Okay, why do you have to know what these are? You must know your answer so that when we do the Netflix problem and we're in groups, the first thing you got to do is tell them what was your favorite problem. Of those problems, which one did you put? So that's going to be in your group of 3. And now I want you to brainstorm with your group about a real life in quotes, data science problem. So imagine you're all data scientists working for Netflix. You have ratings on a scale of 1 to 5 stars for many users and many movies. So every time a user clicks 4 stars, 3 stars, you have a list of all those. And your job is to come up with a model to predict how much a given user will rate a given movie they haven't seen yet. So your job is to take the big database at Netflix and tell me, before I watch a movie, how many stars will I give that movie? All right? There's 4 questions I want you to think about that are all part of the data science pipeline here. Data wrangling. How would you organize the data in the computer? How do you think about the data? How do you store it? What kinds of techniques will you use on it? Predictions. How will you, quote, learn about users or movies? How do you make predictions? Ethics. Are there any ethical issues about this data or this task? Is this an okay thing to do? Or is there going to be some things we should be careful for? And last but not least, testing. How would you evaluate whether or not your predictions are doing well? So how will you figure it out? So those are the 4 parts. Any questions about the task? All right, so make your group of 3. Pick approximately 3 people near you. I guess 2 other people near you. If you're off by 1, like if you have 2 or 4, that's also fine. But try to do 3. And I'll give you guys like 5 or 10 minutes to think about this, and we're going to take it up and just have a little discussion here about all these different things.
Hi, what's your name? Stephanie? I'm Zemo.
I don't have a favorite one. I just put I did the most. I don't have my favorite one. I just put what I did most. Me too. The first one was also very well. That was me.
Yeah, you can join with these 2.
So we need to rate make a prediction of how a given user will rate.
So how would you organize the data into your computer? How do you think about this data?
So first is data wrangling. Yeah. Organize the data.
I think for organizing, you can use data, but like I don't know what they're asking because like how to shift it, or if it's like how you try to leave it with what do you guys think?
Oh, I think we already have the data. We have
Yes, you have the data. So they're saying how would you, first step is how would you, like you have to organize it. When you have data, you put it into a system, whatever you're using to like analyze it. So they're asking how would you organize it? How would you put it into your system?
I think by year, like for chronologically, by like the movies year.
It can also be, it can be the user movie genre, then users. You can't say they're mostly watched because it keeps their attention to Netflix. They don't have the past record. I know it can be movie genre.
Movie genre and the year that was produced and the
Why do you
and
yeah. Why do you
because some people like old movies, some people like the brand new movies.
on that genre? Because you know there's some like 90s,
Oh,
you know?
okay. Yeah, okay, I see what you mean.
Yeah, they can be like 90s romance, something like that. I don't know, just
Oh, I see what you mean. So like by users, like favorites, genre, and then
genre can encompass both whether it's romance or horror or whatever, and like time. So like 90s romance, or like 80s mystery, or like history. You know, things I'm just getting.
yeah, I think that makes sense.
So you can have movie names. You can have movie names. Wait, that's okay. We think about it because we know. I think to answer this is because of what we want to do, right? From the data. So we want to be able to tell what the user loves most.
Yeah.
Enough to say, like, if I'm so used to watching like romance, I'm sorry, using romance, I just love see that I keep like watching movies and there's like movie that's like mystery. And I'm suggesting that you can guess that I would probably pick like one or two because I don't love it so much.
Yeah.
So, right, how do you think about this data? Think about this. You have to look at the user's preference and their history, what they've been watching. I think the user is the primary important. Yeah, so like, so we're organizing it based on things we need from the user. So like movie name, movie genre. Is there anything else you think? Like any table that we need to organize it under?
Yeah, I think that makes sense.
That's okay.
Yeah. And then we can do next. How would you learn about users? How would you make predictions?
I feel like it's basically classified by you guys have expectations. Expectations. Like you can calculate for each expectation. And you give like a reasonable prediction of what if you fall into this year, what will be the score of life, like it's 1 to 5, and you get an average of that.
Okay, yes, I get what you're saying.
Because some movies are like
I get what you're saying. Continue. I'm saying continue.
So it's like the first axis should be the customer, the second, the y-axis should be the genre, and you get a data set, and each of them is a subdata set of the raw data, like classified by the name of the does that make sense?
Yes, it does. Makes perfect sense. So that's how we can learn. Yeah, that's how we can learn like make predictions. And then ethics. Are there any ethical issues about this data or this task?
Like acknowledge the source of the data.
Sorry?
Acknowledge the source of the data.
And I think ethics in the sense that like you know how like before you use some sites they tell you do you like want the cookies thing.
Yeah.
So like you're signing off like yes, like you can all privacy to privacy. So I think that's also something that falls under ethics. You have to take permission of user before taking their data. And then testing, how would you evaluate whether our predictions are doing well? Oh, we don't have time.
Oh, how would you evaluate? Oh, I think what we can do is, so we have a testing set and forgot the name. So we have a model set and a testing set. So it's the same people, 80% are doing tests, 20% are, or 50-50. 80% are doing data and 20% doing tests. And then we can test our model on the test population.
So typically for training, yes.
Yeah, training and testing.
Training and
I think
testing.
training
I
and
did
testing.
machine learning
Yeah.
class last week, and they literally spoke about this. For training and testing data, 80% is to train the data, 20% is to test.
That's what I want to say. Yeah.
So it's like data model analysis.
Check the result and the model.
Yes. So 80 to train data, 20 to test. So that's how we can test and evaluate application.
Have you guys learned this before?
I think we did the same kind of practice before. Right?
Okay, let's come together and have a little discussion about any of these items. So of course, in 7 minutes, you cannot solve the whole problem, but we can get some ideas and just start talking about it and kind of brainstorm. And I think this is going to lead us into a lot of the ideas from the course. Okay, so let me get a blackboard. This is a blackboard, or rather a whiteboard. And we had 4 questions. We had data wrangling, right? So how do you organize the data? What kind of steps would you take to kind of get it onto the computer? Data wrangling. We had predictions. We had ethics. And we also had testing. Okay. Would anybody like to be brave and lead off the discussion on an idea about any of these 4 different questions? You can tell us which question you want to talk about and what your group thought about. Yeah,
Can I stand up?
sure. If you want to stand, that's fine. You're not obligated to stand.
So we decided to categorize the ratings, like 1 as a very poor, then 2 is poor, 3 is average, and 4
Okay.
is good, and then we classify.
I see. Okay, so which question are you answering? Data wrangling, predictions, ethics.
Data wrangling.
Data wrangling,
The
okay.
data.
So on data wrangling, your idea was, let's think of different categories.
Yeah.
Okay, and the categories are, you said like good, bad, something like that.
Very good.
Okay, very good,
Good.
very good, good, okay,
Average.
average,
Bad and very bad.
bad and very bad. Okay. All right, and what do these categories have to do with?
The 1 rating is given to the very bad.
I see. Okay, so these are the
Yeah.
people who put in 1 to 5 star ratings.
Yeah.
You are thinking of them as this is 5 stars. So I guess let me do this in a different color here, because this is from the actual users. We have 5 stars, 4 stars, 3 stars, 2 stars, and 1 star, and we're kind of attaching these labels to them.
Yeah.
Okay, and then what?
Then we can do a multivariate classification.
Okay, a multivariate. This is great. A multivariate. Let's write this down because this will come up in the course. Multivariate classification. Okay. All right. So you gave me 2 words. Multivariate. There's no way that's spelled right, is that?
E after E, variate.
Okay, thanks. Okay, so there's 2 words, multivariate and classification. You're gonna have to tell me what both words mean, because I don't.
Okay, so multivariate is simply like more than 2 variables.
More. Okay, so what are other variables?
So we have talked about, and the variants variate are the categories.
Okay.
Like target value, the one we have to predict. So
Okay.
it is the categories, and then the.
So because we have more, if we only had 2 categories, it would not be multivariate. Because
No.
we have many categories, it is multivariate.
Yeah. So
Okay.
we also have like genre of the movies.
Genre. Okay, so you're gonna add some new information,
Yeah.
like the genre. So add new info, like the genre of the movie. Like, is it an action movie? Is it a comedy?
Yeah.
Okay. Anything else you would add other than the genre of the movie?
And also then the identifier of the user, like if
okay.
specific.
Email ID or something.
Okay. So you're gonna add new info, like the genre of the movie and stuff about the user. So like I guess you said the gender of the user.
Like the identifier of the user, anything like
Login credentials.
phone number.
The
is
phone
very
number?
not
Okay.
critical, but the
All right.
email
Phone
ID
number. Got it.
or email ID. both are okay.
Okay. So these are things we're going to try to use the information to try to predict
Yeah,
how much they like the movies.
yeah.
I have a hypothesis that the phone number does not tell you a lot about which movies they like. Do you agree
No,
with that?
like it specifies the user, like for this.
Okay, okay.
Yeah.
So this is not actually information about the user. This is just who is which user.
Yeah. And,
Okay. So why don't we make a user ID? All right, user
yeah,
ID.
user ID.
All right. Well, we'll just give them a number. You're user number 1. You're user number 2. Okay.
And the classification will be done on genre and categories. Like for what genre, the more categories are there.
Okay. So like comedy action movie.
For horror, like 5 stars more, and for the comedy, like 3 stars. So then, when the new data will come, like a name of the movie, there will be associated genre, so we can.
I see. So do you want to add the name of the movie to our list of information here that we're
No,
going to
like it will be in the testing data. There will be no name of the movie. Like
Okay.
it,
Oh, so we're gonna have the movie ID. Okay. Right? If there's no name of the movie, we'll just say this is movie number 1, movie number 2. This is what you're talking about.
yeah. So
Okay.
the movie ID will be unique, and the genre will be also.
I see. Okay. So let me summarize what you told me so far. So we're gonna have a movie ID for every movie.
Yeah.
We're gonna have a user ID for every user.
User.
We're gonna write down the genre of all the movies.
Yeah.
Okay, so every movie ID we're gonna write down, is it an action movie, is it a thing, and so on. And then we're gonna use these as variates in our multivariate classification.
Yeah.
So that's what multivariate means. We're gonna use this information.
Yeah.
And what does classification mean?
Classification means like in testing data, we will classify this data like as a bad, very bad. and
Okay.
like that.
So multivariate, this is like the input side. This is what we use to make the decision. And the classification is like on the output side.
Classifying the
Okay,
category.
and we want to say, so let's do it in a different color. We're gonna say, is it
Any of the
a 1 star, or a 2 star, or a 3 star? Which category, which class?
Yeah.
Which class is it in?
Mm.
Which class is it in?
Yes.
Okay, and, okay, I'm getting the gist of your idea. So, let's get a little bit more specific. Actually, let me leave it like this and open it to another group. Is there anything another group thought about that they'd want to add to this? Yeah,
Can we see?
you should say, yeah.
I think we can add multiple things to like genre of we can add lead actor of the movie.
I see, the actor, so you wanna add more things that will help us.
And both user also, like gender of the user.
Okay, so let's make user info over here, and movie info, and this is like, this was not in the originally specified problem, right? In the original specified problem, I said you have these things, like I'm the CEO of Netflix, I'm like, hey, Mr. Data Science person, right? Here is the stuff we have, please come up with a way, right? But your job as a data scientist is to think of like, okay, well maybe we could get this stuff, and that would really help us out. So you want to make a list of user info. So for every user, write some stuff down about the user. For every movie, write some stuff down about the movie. So far, we have genre. And I think you said like
Actors, lead actors.
actors,
Yeah.
actors, actresses.
Like a previous IMDb rating.
IMDb rating. Okay, that's a good one.
Then the release year also.
Oh, the year. Yes. Okay. Very nice. Year. And so, okay, what about user info? What should we put in?
Gender, then age.
Age. Okay.
Age of the user, gender of the user.
Yes. What else?
I'm thinking about something.
Or the country from which they are.
Yeah.
The country. Okay.
Language.
Language. Yeah. Okay.
Yeah.
Very nice. Very nice.
Same goes for language of the movie too.
Oh yeah. Okay. Yeah.
And country of release, like.
Yeah. Very nice. Okay. So your idea is we're gonna have, for all the users, we're gonna have this stuff. For all the movies, we're gonna have this stuff, and that'll help us classify. So we'll have a big machine that inputs all this stuff,
Yeah.
and outputs, is it a 1 star or is it a 2 star? Which class do we think it is?
Which class the user will choose.
Yeah.
The new movie will.
Okay. All right.
Or we can use the neural networks.
we could use, okay, this is, so far I think we've mostly talked about data wrangling. We've talked a little bit about these other things, but we've mostly talked about data wrangling. We're like, how are we gonna organize this data? And we sort of have two extra things now. We have this user information table, we have this movie information table, and we're gonna combine that with the thing we were given, which was the list of movies and users and the ratings, and we're gonna combine these three things together. We're gonna use sort of these things as inputs, and the output, you've told me sort of what the output is gonna be. It's gonna be which class is it gonna be in. Do we think it's a 3-star, a 4-star, a 5-star? But now I think we're getting into the question of predictions, of like how exactly are you gonna take these things and combine them? So take these three data things, this one, and the last one which was given to us, which was, I don't know, it's like user ID, movie ID, rating, data set. And that was given to us in the problem, right? Given. So this is like the third important one, and we're gonna sort of use these things that you guys came up with as input. We're gonna somehow combine it with this, and we're gonna get a class prediction. Okay. But now the question is, how exactly do you do that? So what in the predictions? How are you gonna come up with these predictions? So suppose you know everything about the user, you know all these things, you know this stuff about the movie. How does that tell you? Is it going to be a 4-star or a 5-star? How would you do it?
So we can use a neural network and then we can, and the user can, and we can split the data into two halves, the testing and the training data.
Okay. This is going into another question on here, which is under testing. Okay, so you're saying split the data.
Yes.
Split the data into 2.
You can use 3 also, sir. Maybe validation.
Okay, into
and
question mark. Some number.
Training, testing, and validation.
Okay, well, let's split it into some other data sets. We're going to have a training set. We're going to have a testing set. And we're going to have a validation set. What on earth do these things mean? What does this mean? Okay, what is testing? Let's do I think the most concrete one, testing the model.
We know the answer to that, like the
Yeah.
user has already starred that movie a 3-star.
Right, okay.
And what does our model predict that the user will say?
Okay. And then what do we do? What does testing mean?
So
I think you first have to look at the user's history. So it has to be like a thing of, like how much they've been watching, what's they're watching, the genre it falls under, language, where it was from, like the properties of that movie.
So yeah, this is like it's really easy to just say the words split the data. But what exactly does split the data mean? Does that mean I take a user, I completely remove that user from the data set? Or do I take the user and I just remove one movie? Right? So like split the data is kind of underspecified. Like you have to get more specific. So do you want to include like most of their history and just like predict the next movie they will predict? Or do we want to like completely delete a user? Or do we want to completely delete a movie? Like split the data in this particular problem because we have these three kind of tables. We have the user info, the movie info, and this user movie pairs with the rating. It's not so clear what it means. In a lot of problems, it's simpler, right? In a lot of problems, you just have one data set. You got these are the x values, these are the y values. Split the data set, it could only mean one thing, right? But in this problem, split the data set could mean many different things. So it could mean we split the data here, we split the data there, we split the data there. We do kind of all three. What does split the data mean?
Can we just mask some of the data, like we use that
Okay,
data to
but
train?
mask which one? This one, that one, this one, all three?
Collective.
All three.
Yeah.
All three.
collective.
Okay, so we're gonna cover up some users entirely
Yeah.
from this. We're gonna cover up some user movie pairs, and we're gonna cover up some
You just
some
like,
movies.
I'm new to this. I don't know.
Yeah, no. This is.
Like every-
By the way, this is. Don't be fooled into thinking that when you walk into intro to data science on the first class, you're supposed to know all the answers, right? The whole point is to come up with the questions that the people answer. So instead of me just telling you, here's what we're doing this, and then we'll do the next thing, let's take a minute and think about what kinds of questions come up and where do they come up in real life, and why we need like a data science course at all, right? So it's okay if you don't know the answers, it's totally fine. Yes, but this is the kind of thing you gotta think about. So split the data, this is a nice idea, but you got to think of what it means here. So are we going to cover up age and gender and country and language and so on for the users, or are we going to assume that we know that for every single user and we're just trying to predict movies? Like you could mask only this one. That would be a reasonable thing to do. You could also say, I want to be able to like do it even without that knowledge, right? And then you could mask that one. So there's many different ways. There's no right or wrong way. So I'll add this word because you guys used it, mask. It's a nice word. Mask means cover up some data that you already know the answer to. And the advantage is if you cover up data you already know the answer to, you can pretend that you can run your model as if it didn't know that, and then you actually do know the answer. You uncover the mask. So this is the idea of the testing set, which is answering this question over here. And so now you have sort of a philosophy of what's going to happen, right? We're going to have this thing where we do know the answer, but we're going to pretend we don't know the answer until we make a prediction, and then we can compare the prediction to the actual thing. Okay, but crucial question, what does compare the prediction mean? So the idea is compare the prediction, but what does that mean? Compare prediction. Okay, so we're going to have some output that tells us, what we think it's a 1-star or a 2-star or a 3-star. And then we're going to compare the prediction. So let's pretend our model thinks it's a 2-star movie and it's actually a 3-star movie. Is that good? Is that bad? What does compare mean?
It's totally wrong.
Okay. No, this is not totally wrong. So this is another good question. I'm gonna send you guys back in your groups in a minute so you can talk about some of these ideas. But so this is one thing. In testing, what does compare prediction mean? Like how would you actually compare it? I won't answer it now. I'll send it back to you guys in a second. So we've talked a little bit about all these things. For predictions, we said a neural network, or somebody said a neural network. Does anybody have an idea other than a neural network? In a lot of sentences, you can copy paste the words neural network and replace it with magic. It doesn't change the meaning of the sentence. So if someone says use a neural network, you must use magic to input all these things and output something. So we will talk about neural networks, and then it'll be less magical then. But other than neural networks, is there an idea on the predictions front on how you could input user info, movie info, and this thing? Can you say that again?
Clustering the data.
Clustering the data.
Yeah.
I see. Okay, this is a nice idea. Let me write this down. Clustering. So another idea. Let's put this in. This is like our brainstorm board with all sorts of stuff. So clustering, the idea. And I guess the idea with clustering is if you somehow imagine that there's users that are similar to each other, then maybe those users have similar ratings.
Yeah.
So when we want to estimate what is the rating for a given movie, we find other people who are like that user.
Yeah.
And then we say, you probably think the movie is the same as those people. Yeah, this is a nice idea.
Same age group and similar
Okay.
kind of movies.
Yes, and this one's a lot less like magic, because you can imagine if I have a bunch of people who rate movies similar to me, how I would combine the ratings to get a rating. I could take an average or something, right? If you thought it was 4 stars and you thought it was 5 stars, then maybe I think, well, it's 4.5 stars or something,
For
somewhere
example,
between 4.
The movies with higher IMDb rating, they may be getting
Right.
more stars.
Okay, so this clustering idea is a little bit more hands-on than the neural network idea, which at least like when you first hear about neural networks, it's a little bit like magic. You put it in the magic machine, and the magic does something, and then you get the answer. So clustering is a very nice hands-on idea. We're going to talk about this. This is going to come up in the next couple of weeks, this idea of clustering and who's close to you and so on. Okay, so we've talked about data wrangling, predictions, and testing. Any other comments to add before I send you guys back on those 3 questions? Data wrangling, predictions, or testing? Yeah?
Could you use like a regression for a prediction?
Use a regression.
Yeah.
What does that mean?
Regression model
Okay.
that has like factors that
Okay.
are determining what kind of movie the person would like to
Yes.
watch.
Okay, so I heard regression model. This is this would go under clustering. These are other ideas. So I guess neural networks was one idea, and these are some other ones. These are great. Neural networks. Okay, and regression is another one. Regression, and in data science, the word regression is sometimes overloaded. So sometimes it means more than one thing. But you also said factors. So I think you mean linear regression, where you add up a bunch of stuff. Is that what you mean?
Yeah.
Okay, so I'm going to add the word linear, even though you didn't say that. just so we don't mix it up with the other types of regression. And in this one, you sort of take each of these factors, like what is their age, what is their gender, what country are they from, all these things, and you assign like a score to each of them, and then you add up all the scores to get the answer. And that's why it's called linear regression, because you're adding stuff. And this is a very common idea. This is actually what we're going to do in the first 3 weeks of the class, is linear regression. So we're going to get good at this one before we understand the other one. So this is also another nice idea in predictions. Okay, look at that. I even used the same color for both. I'm great. Okay, any other questions or comments about those 3 questions? All right, let me address the elephant in the room, which is the 4th question. Nobody wanted to talk about the 4th question. So the 4th question is ethics, and let's not say anything about it now. Let me send it back to you. I need a 4th color. Okay, we're gonna do yellow. Okay. So I'm gonna put you back in your groups. You're gonna keep discussing, and the things you gotta answer is in the plan that we come up with. Now we have a plan. You can answer a more concrete question about ethics. Are there any ethical issues? Is Netflix gonna get sued because of what we're doing? All right, so you think about that, and then the specific thing I want you to think about is what does it mean to compare a prediction? Okay, this is an important question. So we said test. So we have our model comes up with a prediction for a given user in a movie. We have the real answer because we covered it up, we masked it out. Now how do we compare? What do we do? So think in your groups about how you would answer that question or anything else that we sort of left. I'll give you another 5 minutes and we'll come back, okay?
I think for the compare prediction, we just give a percentage. Like how similar is, for example, if I give a 4 and I actually if I give a 4 for the customer rating, I really get a 4, that's 100%. If I give a 3-star and it actually is a 4-star, that's just 3/4 of just 75%. And then we see, and we set a threshold. For example, if we think 75% is a great threshold, then if it's more than 75%, then we think it's a great model that we use for the rule, right?
Yeah, that makes sense.
And what she said, there should be some kind of an error rate between the predicted result and the real result. And you can set a limit. Yeah, it's like you can set a limit to the error rate. If it's too high, that means our model is not good. If it's higher than a specific number, that means our model is not good. If it's like
I think we have a ratio, like compare like a trained test, like a threshold, like similar to what he said, arrow, like a range. And if it's higher, maybe.
I learned it as margin of error. So like if it's over a certain percentage, basically what you said. But okay, so what do we compare with test data?
We are comparing like the rating, right? Comparing how much the training. Because 80% from training, 20% from test. So we compare the 20% to the 80%. Compare if the rating really match. If it doesn't match, then
well, so the linear regression outputs a number, but there are many ways you can torture numbers and do other things. So it's true that when you add up a bunch of stuff, adding numbers, definitely are numbers, but that doesn't mean the number is the final thing. You take the number, you can do something else with it.
no, like in the beginning of the test, the beginning of the model, we just set 2 sets, one training, one test. So we
Yeah, so one thing you can do is you can apply a function that takes any number and converts it into a number that you want to apply. So it's like your linear
no,
regression
at
outputs
first
1,000,
we
you're
have
like
X, we just
4.9.
yeah, and then we randomly set, so we don't see the like max, we don't see the 20% data. And when we do the test, we could see
And also like in
if the 20% really matches the prediction that we get from the 80% data.
Yeah, right. So technically,
it will be multiple.
right. So a lot of people use these words like sort of interchangeably. So if you read linear regression, often they mean
Multiple.
yeah. Right. And actually, the people won't even say linear.
Do you guys
Just say
remember like every time you register
So,
for
yeah,
that
you
part of
gotta,
the
like,
space,
adapt
you're asking
to the
for your
variable.
gender,
Yeah.
language,
So
age.
I think it would be more accurate to say linear model, because the main idea that is being preserved is that you're doing a combination of the things and you add
It's
them.
actually not a legal thing for the QA, so you can put some kind of disclaimer. The board or something like you pay for the insurance and you can pay for it. We want to do this in your data.
If you come to example, so if the agreement it shows that we need you this, this, and this, and then later we start taking something else that we didn't have, something like that's what's in the page.
That's a breach.
Yeah, but if I told you everything you need, I can still click it. Like I feel like we all do, just clicking without reading.
90% of the time you don't read the terms and you just read it and read it.
Yeah, so I think they're like they're not like breaching anything. Do you want to talk about
Okay, time's almost up. Since the room has gotten quiet, why don't we finish 30 seconds early? And let's get some more discussion. Anyone have any good ideas about, actually, they don't have to be good ideas. Any ideas about any of this stuff? Yeah.
Sir, you asked about compare prediction, so
Right.
we can say that we can calculate the accuracy of the model.
The accuracy, okay. I love this. Okay, the accuracy. So the model thinks it's a 4-star. It
Yeah.
either gets it right or wrong.
Yeah.
And then if it's right, we count up how many are right, we count up how many are wrong, and the accuracy is how many you got right divided by the total number. Okay, how many you got right? Great idea. How many correct divided by total number? All right, fantastic idea. So, once again, in this idea we're taking some of our data, we're not showing it to the model. Okay, so it's masked, it's covered up, the model doesn't see it. We use one of these methods to come up with predictions using everything else. And then we test how well we're doing on our little held out test set by saying, did you get it right or wrong? If you thought it was 4 stars, you either got it right or wrong, it was either actually 4 stars or not, and we will count up the accuracy. Very nice idea. Did anybody have any other ideas? Or, yeah?
From the accurate, right answer, how far, the movie is 4-star. How far the data is,
Okay.
It 5-star or 3-star?
So this is not, so accuracy is how you either get it right or wrong, right?
Yeah.
We said it was 4-star, it's either 4-star or not. You're either thumbs up or thumbs down, yes or no. But you're saying we should look at the difference.
How far
Yes, like a margin of error, like something.
Right, so that would be like the error, I'm gonna put the word size in there. Error size, okay? And you're saying how far away the prediction was.
Yes.
So if you thought it was 4-star and it was 5-star,
Yeah.
that's like better than if you thought it was 4-star and it was 1-star.
Yes,
Yeah.
exactly.
Okay. Okay. How big error is. Let's say on average, let's say. So there's a big data set. We average up over all the different things. This one has some error, this one had some error. We got like 100 of them, we take the average. By the way, the accuracy is also, if you get 1 point for getting it right and 0 points for getting it wrong, the accuracy is also on average how many points you got. So that makes sense? Okay, so error size is different than accuracy. We also need to kind of specify what big means. How big is the error, right? So is
We
it,
can assign a value to it, 1 to 5 is 1.
okay, so
5 4.
so you subtract them, is that what you're saying? You
Yes.
take the difference, so how big the error is equals the difference. The difference.
And also the positive or negative, it was 1 star and it is.
Okay, yeah, this is, I was gonna try to get you guys with the difference. The differences are sometimes negative. So you have to make sure you don't have a negative error. Let's do the absolute value of the difference. Absolute difference between prediction and not. And true value. Okay, true is in quotes because it's like whatever the user said, right? Like that's the true value. Okay, so that's 2 different ideas. Should we do the accuracy, or should we do?
I think accuracy is harder to get. You know, I feel like if you know, like we were saying, if you can get we're calling like margin of error, like you can get but with accuracy, if it's not 4 stars, even if your model isn't like, you know, sometimes your model isn't 100%, like if you work with machine learning and like you make models and stuff, sometimes it's like at the end of it, it's never like 100%, it might be like 92.95, so you might still have like, you know, like those mistakes. So I think error size, like the second
Well, I think the thing is like, both ways of looking at it, I don't think you're going to expect the model to be 100% accurate, or 100. You're not going to expect the model to be perfect either way. So perfect in accuracy means 100% right. Perfect in error means 0 error. And I think both of those things are too much to hope for. We're not hoping the model will. So either way, the model will do something. But it is our job as the data scientists to decide what are we aiming for, right? Do we want the model to make the accuracy as high as possible, like get as many as you can exactly right? Or do we want to minimize the error, like get as many as you can that are like close? And this is your choice as the data scientist, which one you want to do. And actually, in the course, we're going to have a whole unit on one and a whole unit on the other, and you're going to learn how to do both. But you know, the thing we're not going to teach you is like which one do you want to do, right? So that is something you're going to have to think about. Let's do a little vote here. This is one nice thing with the mathematize. Do you think we should try to do accuracy, or do you think we should try to do error size? I will open up a multiple choice question in a second here. Take like 1 minute to think while I make the question, and then we'll have a nice little vote here and see which one you guys think is better. So for this problem, do you want to go for accuracy or do you want to go for error?
The accuracy is tricky because I think accuracy, especially so it makes more sense. But then what's it when you do like you're reaching for let's get so many right, you get so ridiculous 5 stars instead of 1 star, something. So I don't know. It's like pick or choose, I guess. But I think accuracy is what you should always shoot for with creating a model.
Yeah, but I think at the end we don't want to be 100% sure about what a user likes. We want to be maximizing the possibility of having, you know, the right guess. So I think it depends on our ultimate goal. The ultimate goal is to just get a great guess instead of getting it always right.
Okay, so
I think error size is just minimize, right? Minimize the error to make more sense.
Okay, I made the question. I started it. It should be open in your thing. Let's go to present. So I added a third option called other third thing. So if you object to these 2 things as the only option, then please pick other third thing. Should we try to maximize the accuracy, get as many as we can exactly right, or should we try to minimize the error, or minimize, as I would say, minimize the error? Where error can mean, like, I guess you can do something else. What we wrote down was the sum of the absolute value of the difference. So if you're off by 1 star, that's an error of 1. If you're off by 2 stars, that's an error of 2. Add them all up, and then we make that as small as possible. What do you think? Okay, we got 12 people in. Let me do a quick little timer here. I'm counting the number of people in the room. 10. Okay, there's only 2 people who haven't answered yet, so maybe you don't need a whole minute. Maybe I will just say that I'm going to press the button and the last 2 people will enter their thing. Okay, here we go, I'm doing it. I'm going to press the button. All right, I'm revealing what people said. And of course, there's no, okay, so 15 people said minimize the error. 4 people said maximize the accuracy. It might have let you pick more than 1, which hopefully you only picked 1. Nobody picked other third thing. Does someone want to say why they chose one over the other?
I think minimizing error is a broader picture to accuracy only, in my view, but I don't know like much.
Yeah. So the thing is, so in some problems, accuracy is definitely right. In some problems, minimizing the error is definitely right. in most problems, there's arguments to be made for both, and you have to think like a human about what is the real life thing and come up with an answer. And actually, this is something that in math class we're not going to do very much because we're going to be like deep in the math up to our elbows in linear algebra. So this kind of question in real life matters a lot, and you don't see it a lot in math class. And I don't think there is like an absolutely this is the right answer. There's just pros and cons for both, and you can say, I saw it this way, and I think therefore this is the most important thing, and that's why I picked this one. That's all you can do. Yeah?
I was thinking maybe for categorical problems, you probably want to go with accuracy.
Okay.
Quantitative problems, you want to go with like representing them, something like that.
Yes, okay, this is a fantastic way to think about it, and this is going into our 2 units of classification versus numbers. So if we have categories, if we really have categories, 1 star, 2 star, 3 star, 4 star, right? So we said earlier, way at the beginning of our discussion, that we should think of categories. This is the very bad category. This is the good category. You have all these different categories. Very often, when you have categories, the thing you are going for is accuracy. Did I select the thing to be in the right category? So a lot of times when you have categories, you want to maximize accuracy. This is something that happens a lot. On the other hand, minimizing the error, this is like very common when the thing you are trying to predict is some kind of number, like a scalar that can be anything. Like if I want to say, how much does this potato weigh? Okay, I have a machine learning system, a data science problem. I take a lot of pictures of potatoes, and I try to predict how much they weigh, so we can get the heaviest potatoes, right? Well, a potato can weigh any number. It's not like 1 kilogram or 2 kilograms. It could be 1.3 kilograms or anything. And in those situations, you very often minimize the error, right? Because how close you are makes sense to when it's 1.3 or 1.5. You want to, get it as close as you can. You're never going to get it perfect. You want to be as close as you can. And now the question is, which one are we in, right? Is this Netflix problem? I didn't tell you what it was. In real life, nobody will ever tell you what it was. Of course, in examples, they will tell you. But in this problem, I never told you, is it categories or is it numbers? Right? You have to decide what you think is better. So people chose minimize error, even though we earlier said it was categories, right? And if you're minimizing the errors, it's like you have categories, but the categories aren't just categories. The categories are somehow in some strict order, right? Like there's some notion of closeness. Like this category is closer to this category than this category is to that category, right? Good is closer to very good than good is closer to very bad.
Yeah.
So do we need categories at all at that point? Why should we limit ourselves to categories? Like what if our machine learning model, our magic or whatever, our data science prediction, what if it outputs 3.5 stars? Is that okay? Could we have if the thing can't decide between 3 and 4 stars, should we let it say somewhere between 3 and 4, or should we force it? You gotta pick one, right? This is something you gotta think about. So we started with saying a classification, and now you guys all pick minimize error, and it's making me think maybe we don't need classification. And once again, there's no, this is the answer. Because in real life, there is never, this is the answer. There's just pros and cons for both, all right? And I would say in this particular example, I think I wouldn't think of it as classification. And it's again because numbers already have this beautiful property that the number 5 is closer to the number 4 than the number 4 is to the number 1. We already know that about numbers. Why don't we just output any number, just like the potatoes, and we'll just see how close we can get, right? The categories, they're there for the humans, so the human can select a category. But if we could get even more detailed information from the humans, like if we could measure their pulse or something and get a 4.5, we'd be happy with that too. So in my view, we just run it's really a spectrum of really bad to very good. These categories in the middle are artificial and are not actually helping us solve our problem. But of course, you can argue, and it's not like I'm right. It's just that's the way I'm seeing it. Any comments? You got your hand.
I think it was a Netflix model to judge that a person would like a movie or not, right?
Right. Yes. Okay. So I made this question a few years ago, and I've been using it for a while. And in my day, Netflix really did ask you 1 to 5 stars, and Netflix has now switched to thumbs down or thumbs up or double thumbs up, which is my son's favorite thing to click. Every movie is double thumbs up. But they used to have this, and they don't anymore. And I think it was partially, even though it's 1 to 5 stars, and you think of it as numbers, humans don't think of it as numbers. And humans are kind of unlikely to pick like 3, you know, like psychologically, there's some kind of like psychological layer here that is affecting our interpretation of numbers that is making the error thing harder to do. And this is a good argument that you do need categories, right? The humans who made this are these weird like monkey beings with their monkey brains, and they look at the categories, so we better have categories in our math, right? If we don't have, then we're not doing it right. Like, yes, it's numbers 1 to 5, but that's not how people are thinking about it, so don't do that. Totally valid. Yeah.
I think a great way to think of it is we first start to think of it as a numbers problem, and then we turn it into, for example, 3.5, we can round it up to 4, and then it could be a category.
Right, yeah. So in fact, you're going to see when we get in this course, so this is one of the major themes of the course. So this thing is called a classification problem. Classification. And you have categories, and you do accuracy, and this kind of problem is called a regression problem sometimes. And again, it's confusing because earlier we said something about linear regression, and this is a regression problem, and it's the same word, but it's kind of like 2 different meanings. So don't, this regression has nothing to do with this regression. I mean, okay, it sort of does, but okay, pretend they're 2 different words. And we're going to see that one of the ways you can do classification is you can first do regression and then like torture it a little bit to make classification. So, and that's exactly this kind of like rounding thing that will come up there. So, yes. Yeah, and there's no right or wrong answer. It's just different ways of thinking about it and what you think. I think you want to try to get as close as you can. Other people could make an argument another way. I am very curious, was anyone at all tempted by other third thing? I know nobody clicked on it. Was anybody tempted by other third thing? Let's pretend I'm the CEO of Netflix, and you have a meeting with me, and you're trying to explain what you're doing. And you're telling me about, oh, I thought of it as classification, we want to get the stars exactly right, and like, what am I going to say to you in our office, in our short 5-minute meeting? What would the CEO care about?
The good predictions.
What was that?
The good predictions.
Yeah, do you think the CEO cares how accurate it is? If it's like really accurate or like,
Engagement
what does he
of
actually
users.
care? What do they actually care about?
Engagement of users.
Yeah, right. So
Like more.
the CEO is going to say, look, just which one's going to make us more money?
Yeah.
Like, I don't pick whichever. I want the one that makes me more money, please. So, you know, actually, maybe there's another third thing, and like we should think about like what are we really trying to do? Are we actually trying to get them like right on to like make better movies, or are we actually trying to like figure out, is there like a crucial segment of movies where the user wouldn't watch it, and we can switch them from not watching the movie to watching the movie, right? Like we can like find the movies that they would like a lot if only they knew about it, and we can like focus all our effort on those movies or something. So other third thing I think easily could be the right answer as well. Yeah.
So I thought if we should do it as a classification problem.
Okay.
We do like obviously what it would be like that.
Okay.
The area under to test if the model will or not.
Yeah, but so you still have the categories 1 star, 2 star, 3 star, 4 star, 5 star, or you're gonna have different categories?
I think it was the same category.
Same categories, yeah. Because another thing you could do is you could say maybe the only thing that matters is do they think it's a good movie or not, right? Like maybe we could group 4 and 5 together, and then we could group like 1, 2, 3 together, which is kind of what the real Netflix people have done with their thumbs up, thumbs down, or something. So you could say it's classification, but not the stars as well. Lots of different ways to do it. Okay. All right, fantastic discussion. Okay, that leaves us with the last question, which is the ethics question. Is anything we've thought of so far, are there any ethical issues with this stuff? Yeah.
No, I don't think so. Because I think just like when you sign into like new websites and things
Right.
like that, they always ask
Mhm.
if you're fine with them accessing your data, or like some websites
Mhm.
use cookies. So I think if you're already granting to that, that's
Right.
why we should actually read the
Yes.
fine print. But then if you're like reading through
Yes.
and you see they want to have access to my age, for example, I'm not fine with that. You click off. You don't
Right.
use.
So I think you have an excellent argument that it's like legally okay.
Yeah.
Right, I agree, legally okay. Is legally okay the same as ethically okay, in your view? Like just, if it's legal, then it's okay? Like that's a...
Okay, obviously sometimes that doesn't work. But I think there's nothing
Right.
like extremely invasive that we need so far that I've seen. I mean, like obviously this is not just a like 1 hour process. Like it's exactly. And like aside the fact that it's entertainment based, this is obviously not just like a 1 hour like sit down. It's a project like you take on for a couple months maybe. So like maybe with time when you start digging into stuff and you're like, okay, maybe we'll need this from the user and I don't think users are fine with this, then you can start to like, okay, well, I think we're going to be breaching a contract somewhere. But then so far I think everything we'll need is like stuff people, I would say user will be fine with.
Yeah, I think one thing you mentioned I think that is really important too is to understand the stakes, right? Mm-hmm. This is like worst case scenario. It's like movies, you know, and like what you think about movies. It's not like somebody's like life or death or like health or something. So the stakes are already like upper bound, like not that high. This is absolutely true. So this is something to think about with the ethics is like what scale are we talking on here? Like how critical is it that we get it like sort of exactly right? Or like is there a little bit of wiggle room because it's at the end of the day it's people, it's entertainment. And so I totally agree with that. And yeah, you're saying people would not care.
It's like we're not providing the personal details like the phone numbers or email ID sent, the actual address, it's just the basic information like the age, gender. So I think.
Yeah, so and this is another point of view. You can have you say this is basic stuff and it's not so invasive and therefore it's probably fine. Yeah. Does anybody want to argue the opposite? So some of these ones, the movie info I'm totally okay with. But the user information, if I was the CEO of Netflix, I would be worried that could it be that if people discovered that we are recommending the movies based on this stuff, could they get upset, right? Like, could it be that like, let's give an example. In the country of Canada, people who speak French are like, could they get upset that we're giving the movie recommendations because they speak French and we know that, right? So on one hand, you can say, like, look, we're trying our best to give you the best movie recommendations, but maybe they would get mad that they're getting treated differently or something. Mm-hmm. So I think you could make an argument that like having stuff about the user, and especially how clear you are about what you use and what you don't use. Normally when I use Netflix, I don't enter in my age or my gender and stuff, right? So maybe you could collect this somehow. Do the users know that you're using this stuff to make the recommendations? How transparent are you going to be? One thing you could think about is when we do all this stuff, maybe we could do it with and without their age and gender and so on, and see how important is it. If it's not very important, maybe we should just drop it, right? So that we don't get in trouble just for like a 0.1 star improvement or something, right? So we could ask ourselves, do we really need this? Do we really need this or not? Okay. And in fact, you can do the whole thing without any of these ones. So I know you guys came up with this, but you can just working with just these, you can get almost as good answers. And I will say one other thing you can do, instead of thinking of this as a big list, sort of a big database of user ID, movie ID, and rating, there is one other way you can think about it, which is also came up earlier in the course. You can think about it as a big matrix. So you can put the user IDs as rows and the movie IDs as columns. Okay, I said it out loud, the opposite of what I wrote down. And then you can say like, okay, movie number 1 with user number 3, it was 4 stars. And they didn't rate these other movies. And they rated this movie 3 stars. And what you have here is a matrix with some of the entries missing, an incomplete matrix. So that is another way you could think of this data. Instead of thinking of it as a data set with sort of a traditional, like here are the rows, each column represents some feature, you could think of it as a matrix with movies on one axis and users on the other axis. And this is partially complete. So everywhere we have a rating, it's filled in, but there's a lot that are missing. And then you can do linear algebra techniques on this matrix, this data matrix M, and you can try to fill in the missing things in some way that makes sense as well. And then you don't need the user or movie info. Another thing to watch out for with the movie info is it can be annoying to get, right? When new movies come out, you gotta like get them. So by having this extra thing, can we eliminate that? Like, is this the real source of the good stuff, or is this the real source of the good stuff? You can ask yourselves questions like that. And that one, again, if you get some kind of ethical thing, it's nice to say, look, this is what we have, and this is what we did. it helps defend you from kind of ethical questions in some sense. Not that there could be other ethical issues, right? Like maybe it's unethical to predict people's movie ratings at all, but let's leave that for another day. Any questions or comments?
I think Netflix already knows the location and they recommend movies on the basis
Yes.
of
Already.
movies in
Yes.
Canada, movies in
Right.
Topics for you.
Yes, this is true. Yes. I think I would guess Netflix would steer away from like gender and stuff. And I do wonder what they do in like French Canada if they are careful about that. It's a good question, right? Like the real life Netflix company they have a lot of different things to worry about. So yeah, something to think about. Okay, I will say one other thing. Last year, when I taught this course, there were 3 options for the final project, and this Netflix problem was one of them. So there's an actual data set with Netflix movies and ratings from a long time ago, like 2005 or something. But there really is a real data set with user ID, movie ID, and rating, and you can try to do this. That was somebody's final project. So if you're into this stuff, that could be your final project too. Okay, let's stop there, and I'll see you guys on Wednesday. Make sure you watch the movies or the videos that were assigned for Wednesday's class, so that's where we're gonna start things off.